A refractometer is a laboratory or field device for the measurement of an index of refraction. The index of refraction is calculated from Snell's law and can be calculated from the composition of the material using the Gladstone-Eurodale relation. Types of refractometers. There are four main types of refractometers: traditional handheld refractometers, digital handheld refractometers, laboratory or Abbe refractometers, and inline process refractometers. There is also the Rayleigh refractometer used for measuring the refractive indices of gases. In veterinary medicine, a refractometer is used to measure the total plasma protein in a blood sample and urine-specific gravity. In drug diagnostics, a refractometer is used to measure the specific gravity of human urine. In gemology, the Gemstone refractometer is one of the fundamental pieces of equipment used in a gemological laboratory. Gemstones are transparent minerals and can therefore be examined using optical methods. Refractive index is a material constant, dependent on the chemical composition of a substance. The refractometer is used to help identify gem materials by measuring their refractive index, one of the principal properties used in determining the type of a gemstone. Due to the dependence of the refractive index on the wavelength of the light used, the measurement is normally taken at the wavelength of the sodium line D line of 589 nm. This is either filtered out from daylight or generated with a monochromatic light-emitting diode. Certain stones such as rubies, sapphires, tourmalines and topaz are optically anisotropic. They demonstrate birefringence based on the polarization plane of the light. The two different refractive indexes are classified using a polarization filter. Gemstone refractometers are available both as classic optical instruments and as electronic measurement devices with a digital display. In marine aquarium keeping, a refractometer is used to measure the salinity and specific gravity of the water. In automobile industry keeping, a refractometer is used to measure the coolant concentration and pH value of the coolant oils for CNC machining process. In home brewing, a refractometer is used to measure the specific gravity before fermentation to determine the amount of fermentable sugars which will potentially be converted to alcohol. Automatic refractometers. Automatic refractometers automatically measure the refractive index of a sample. The automatic measurement of the refractive index of the sample is based on the determination of the critical angle of total reflection. A light source, usually a long-life LED, is focused onto a prism surface via a lens system. An interference filter guarantees the specified wavelength. Due to focusing light to a spot at the prism surface, a wide range of different angles is covered. As shown in the figure schematic setup of an automatic refractometer, the measured sample is in direct contact with the measuring prism. Depending on its refractive index, the incoming light below the critical angle of total reflection is partly transmitted into the sample, whereas for higher angles of incidence the light is totally reflected. This dependence of the reflected light intensity from the incident angle is measured with a high-resolution sensor array. From the video signal taken with the CCD sensor, the refractive index of the sample can be calculated. This method of detecting the angle of total reflection is independent on the sample properties. It is even possible to measure the refractive index of optically dense strongly absorbing samples or samples containing air bubbles or solid particles. Furthermore, only a few microliters are required and a sample can be recovered. This determination of the refraction angle is independent of vibrations and other environmental disturbances. Influence of wavelength. The refractive index of a certain sample varies for nearly all materials for different wavelengths. This dispersion relation is characteristic for every material. In the visible wavelength range, a decrease of the refractive index and nearly no absorption is observable. In the infrared wavelength range, several absorption maxima and fluctuations in the refractive index appear. To guarantee a high-quality measurement with an accuracy of up to 0.00002 in the refractive index, the wavelength has to be determined correctly. Therefore, in modern refractometers, the wavelength is tuned to a bandwidth of ±0.2 nm to ensure correct results for samples with different dispersions. Influence of temperature. Temperature has a very important influence on the refractive index measurement. Therefore, the temperature of the prism and the temperature of the sample have to be controlled with high precision. There are several subtly different designs for controlling the temperature. But there are some key factors common to all, such as high-precision temperature sensors and Peltier devices to control the temperature of the sample in the prism. The temperature control accuracy of these devices should be designed so that the variation in sample temperature is small enough that it will not cause a detectable refractive index change. External water baths were used in the past but are no longer needed. Extended possibilities of automatic refractometers. Automatic refractometers are microprocessor-controlled electronic devices. This means they can have a high degree of automation and also be combined with other measuring devices. Flow cells. There are different types of sample cells available, ranging from a flow cell for a few microliters to sample cells with a filling funnel for fast sample exchange without cleaning the measuring prism in between. The sample cells can also be used for the measurement of poisonous and toxic samples with minimum exposure to the sample. Microcells require only a few microliters volume, assure good recovery of expensive samples and prevent evaporation of volatile samples or solvents. They can also be used in automated systems for automatic filling of the sample onto the refractometer prism. For convenient filling of the sample through a funnel, flow cells with a filling funnel are available. These are used for fast sample exchange in quality control applications. Automatic sample feeding. Once an automatic refractometer is equipped with a flow cell, the sample can either be filled by means of a syringe or by using a peristaltic pump. Modern refractometers have the option of a built-in peristaltic pump. This is controlled via the Instrumentally EuroS software menu. A peristaltic pump opens the way to monitor batch processes in the laboratory or perform multiple measurements on one sample without any user interaction. This eliminates human error and assures a high sample throughput. If an automated measurement of a large number of samples is required, modern automatic refractometers can be combined with an automatic sample changer. The sample changer is controlled by the refractometer and assures fully automated measurements of the samples placed in the vials of the sample changer for measurements. Multi-parameter measurements. Today our Euro 1 registered trademark S laboratories do not only want to measure the refractive index of samples, but several additional parameters like density or viscosity to perform efficient quality control. Due to the microprocessor control and a number of interfaces, automatic refractometers are able to communicate with computers or other measuring devices, for example density meters, pH meters or viscosity meters, to store refractive index data and density data into one database. Software features. Automatic refractometers do not only measure the refractive index, but offer a lot of additional software features, like instrument settings and configuration via software menu, automatic data recording into a database, user configurable data output, export of measuring data into Microsoft Excel datasheets, statistical functions, predefined methods for different kinds of applications, automatic checks and adjustments, check if sufficient amount of sample is on the prism, data recording only if the results are plausible, pharma documentation and validation. Refractometers are often used in pharmaceutical applications for quality control of raw intermediate and final products. The manufacturers of pharmaceuticals have to follow several international regulations like FDA 21 CF Part 11, GMP, GAMP5, USP less than 1058, which require a lot of documentation work. The manufacturers of automatic refractometers support these users, providing instrument software fulfills the requirements of 21 CF Part 11, with user levels, electronic signature and audit trail. Furthermore, pharma validation and qualification packages are available containing qualification plan, design qualification, risk analysis, installation qualification, operational qualification, checklist 21 CF Part 11/SOP, performance qualification, scales typically used, Brix, Erxel scale, Plato scale, Balmer copyright scale, see also, Ernst Abbe, refractive index, Gemology, must wait, winemaking, harvest, gravity, high fructose corn syrup, cutting fluid, German inventors and discoverers, High refractive index polymers, references, product page of Acranis Optronic GmbH, further reading, Seller, Andrea. AB copyright S. Refractometer. Chemistry World, 67A, external links, Refractometer Gemstone buzz uses, procedure and limitations. Rayleigh Refractometer, operational principles, refractometers and refractometry explains how refractometers work. Refractometer products and functions.